Welcome to Lesson 20 Super Challenge, where you will predict the number of steps needed to increment in each for loop. These challenges will require you to use decomposition to break down the puzzle. Go ahead and log into Codeorg. Double check that your username is shown in the upper right. You might wish to have a paper and pencil with you to help jot down ideas, algorithms, or for decomposing the puzzle. Good luck in this challenge. Make sure to read directions carefully and read the hints if you need them. You may pause this video now and begin your work. Return here if you need more direction. Puzzle 1. Can you get Scrat to his acorn using as few blocks as possible? In this case, in 13 blocks. For this challenge, I needed to simulate the different routes with my mouse, trying to find some usable pattern. I did find one pattern, but it wouldn't require a for loop, so I'm wondering if they are looking for something else. So I decided to look at a hint. The first hint stated the obvious, considering this is a for loops lesson. So I went for a second hint. The second hint let us know the route that Scrat is going to take. Even though you can probably see the pattern and go straight to it, the point of this video is to help direct those that don't immediately see it. So what I'm going to do is first write out the whole sequence before we look at using a for loop. Now that I have a sequence written out, I'm going to try to match up the different repeated sections to find the similarities. Notice that we have a zigzag or staircase pattern of forwards, left, forwards, right. The amount of move forwards is decreasing each time, so let's use a for loop. And let's put the counter variable in for the variable amount of move forwards. Now, how many move forwards do we start with? How many do we end with? And by how much does it change each time? Great. Why don't you pause now and go on to the other puzzles on your own. Return here if you need help. Puzzle 2. Again, this is a for loops challenge, so we're looking for a repeating pattern with a predictably changing amount of something. For this challenge, you may need to start with some simulations and trial and error to find the right path. The most direct path of going forward, left, forward, right, forward, left, left again, and forward, that did not really show me a pattern that I can use. So then I thought about what if instead of taking this right, we take these loops around, essentially taking only left turns? Forward, left, forwards, left, forwards, left, forwards, left, forwards, left, etc. I wasn't sure if there was a pattern in the forwards yet, so let's write out the whole sequence and see if a pattern emerges. Now that we have our sequence, let's match up some sections side by side. Great! It appears that the part that is variable are these longer move forward sections. The first one was 7, the next one was 6, and then the next one was 5. We might be onto something. Let's put in our for loop. Let's use the counter variable in the repeat with the variable amount of move forwards. And let's put in a start of 7, end of 5, and increment of 1. Great work. Continue on to the next puzzles on your own. Pause now. Puzzle 3. Right off the bat, I see this one zigzag pattern involving the honey, and honey amounts are clearly going down by 2 each time. If that's all we had to do, this would be easy. But we also have these flowers to deal with. Using my mouse, I try simulating different routes that would allow me to get some nectar, then a couple honeys, etc. But that pattern didn't quite work. I decided to check out the first hint, which shows me the route. So it looks like we're first doing a zigzag pattern to get the nectars, then we're coming back through to make the honeys. Just like last time, I'm going to write out the whole sequence without a for loop to help people see where it's coming from. I'm going to start with the nectars. Now that we have our sequence for the nectars, I'm going to match the stack so that you can see the pattern. Our nectars start with 1, end with 3, and go up by 1. Now let me finish the sequence with the honeys. Now that we have our sequence, let's match up some of the stacks. You need another for loop, but this time it's for the variable amount of honeys. Excellent. Continue on to the next lesson. Pause now. Puzzle 4. I see the pattern of 3, 6, 9, 12 honeys, but I'm having a hard time seeing the pattern with the number of nectars. So let's see if a clue shows me the root. Okay, I see the root at least now. The pattern of these numbers is still eluding me. So I'm going to try to write up the entire sequence and see if the pattern becomes easier to see. If I match up these stacks, there appears to be 4 iterations of this pattern, but the nectars here, honeys here, and nectars here are all variable. If they want us to use a for loop, then that must mean that they all relate somehow. Let's set up a for loop for the first variable amount. This one goes from 1 to 4. How does 1 relate to 3? 2 relate to 6. 3 relate to 9. 4 relate to 12. Yes, they appear to be whatever this is times 3. So let's set up some math. How about this one? How does 1 relate to 2, 2 relate to 4, 3 relate to 8? I think we're looking at something exponential here. Phew, you did it. Go on to the next puzzle on your own. Pause here. Puzzle 5. Okay, I'm going to first think about an algorithm for a square. I'm also going to take a look at the first hint. The pen width is 1. We're making a bunch of squares with variable length sides, but the first hint tells us to start with a length of 50 pixels and go up by 50s. But we don't want to have all of these squares start in the same corner. So after each square, we're going to need to get into the next corner. To avoid having to turn around only to turn back around again, let's take a step backward, left, forward, right. which should put us in position to make another square. Okay, the shape is good. Now we just need to get the line colors right. Let's set our color to blue. And each time we make a new square, the line gets darker. The alpha value will set how opaque the line is. One of the hints tells us to set it to counter divided by 2. Great work! Go on to the next puzzles. Pause this video now. Puzzle 6. I see squares spiraling, getting bigger, and changing color. Let's start by making our line skinny and start with an algorithm for a square. We know that the size of the sides of the squares are variable and increasing. So let's set that to counter. The second hint tells us that our counter will start with 5, end at 200, and go up by 5s. Since this is spiraling, let's see if we can use trial and error to figure out how much it turns each time. Now let's put in our clue about the color changes. Set color with red, counter. Green is 255 minus counter. Blue is a constant 255. For the record, I would never have figured that out on my own without the hint. Excellent. Go on to the next puzzle and pause here. Puzzle 7. We're going to have something funky going on with our colors again, so hopefully one of the hints will tell us what to put in the for loop. The first hint does. We know we need a skinny line. And we know we'll need a for loop because the lengths are increasing at a predictable rate. Let's set it to 5 and 250 again like last time. The increment is probably going to be smaller than last time though because the lengths aren't changing by that much each time. One of the hints says to set that to 2. But we aren't completing a square. It doesn't look like it turns enough to be a 90-degree angle, which is why it stays open. Let's use trial and error. Great, pause here and go on to the next puzzle. Puzzle 8. Wow, this is quite the image. If you aren't sure where to start, look at all but the last hint. One at a time until it helps you. Let's set up a color change, like the first hint. Now let's set up 2 similar for loops. Inside each for loop, you move forward 5 pixels before you turn 360 degrees divided by counter, and set brush to counter. You'll need to turn left by 225 degrees between the 2 for loops. Great job completing this super challenge lesson.